Good morning. I hope you all enjoyed Memorial Day and you were able to honor somebody yesterday. We are going to move on in Unit 6. This is Lesson 9. Our goal today, we're going to look at both arithmetic and geometric sequences. So it's actually nothing new, which is nice. We're just going to kind of review everything we know so far.
Excellent.
We are almost done with Unit 6, so yay. Also this week, guys, there'll be no Google form. You're just going to get a lesson with a homework tonight and a lesson with a homework tomorrow, and that's it.
Yeah, baby, yeah!
So here we go. Arithmetic sequence. So we have learned throughout this unit that an arithmetic sequence, shh, it's my dog. The pattern, which we use D to represent the pattern, it's found by adding or subtracting. Okay, just think A for arithmetic, A for addition. Okay, if it's arithmetic, it has to be a linear function. The formula for an arithmetic sequence is A sub n equals A sub 1 plus D times n minus 1. And again, I know it's arithmetic for a couple reasons. Number one, it has a D in it to represent the pattern. So if it has a D, it's arithmetic. Also, there's addition right here. So that's how you would know looking at the formula that it's arithmetic. Geometric was the other type of sequence we talked about. This one we call the pattern R. So if you see an R at any point in time, you know it's geometric. And if it's geometric, your pattern is found by multiplication. Okay, you always want to represent it as multiplication. So if it looks like division, you're just going to change it to its reciprocal, flip the fraction, okay? If it's a geometric sequence and the pattern is multiplication, that means it must be an exponential function, okay? This one, the formula is A sub n equals A sub 1 times R raised to the n minus 1. So a couple things to notice.
Couple of things.
Here, number one is it's got R in it instead of a D. The A sub 1 and the R here, they're right next to each other, so they're being multiplied, which is what your pattern does, is multiplication. Also for this one, the n minus 1 is an exponent, which we learned way back in September in Unit 1, that if you have a variable, x or n is your exponent, it's an exponential function. Keep in mind when you graph these, they're what we call discrete, meaning you just don't connect the points. Okay? So let's look at some examples here. In this one, on this page here, we're just going to identify it as arithmetic or geometric. So we're just going to put an A or a G. We're going to find the missing term and then identify the common difference. So if it's arithmetic, we're going to say D equals this, whatever pattern it is. If it's geometric, we're going to say R equals this number. So whatever pattern that is by multiplication. So here's what I do. I just always first check, is it arithmetic?
Arithmetic.
So let's check our pattern. How could you get from a 6 to a negative 2? Well, you could subtract 8, and let's see if that pattern stays true. Is negative 2 minus 8 negative 10? It is. So subtraction means that this is arithmetic, so I'm going to put an A. I'm also going to, just for good review, I'm going to put an L here because it's a linear function. We just found that if it's arithmetic, we're going to use D. So D, our pattern, equals negative 8. So our next term, if I have negative 10 and I subtract 8, I'm at negative 18, and we're done with number 1. So that's what we're going to do for each one of these. Let's look at number 2, same idea. How could you get from a negative 72 to a 24? Well, to check that it's arithmetic, you might need to, like I can't see that off the top of my head, so you might need to say, well, what's 24 minus the second number minus the first? So minus negative 72. If I take out my calculator, 24 minus negative 72 is 96. So in other words, if this was arithmetic, to get from negative 72 to positive 24, I would add 96. Let's see if that pattern holds true. 24 plus 96 is not negative 8. 24 plus 96 is 120. So this is not arithmetic. So now let's check to see that it's geometric. To check that it's geometric, you just divide. So in other words, to find R, your pattern, you're going to say take the second number, 24, and divide it by the first number, negative 72. And 24 divided by negative 72 is going to give you an ugly decimal that you're not going to use, negative 0.3 repeating. You're going to hit math, enter, enter, and this is negative 1/3. So let's see if our pattern is times negative 1/3. So negative 72 times negative 1/3 is positive 24. Positive 24 times negative 1/3 is negative 8. So that's good. Negative 8 times negative 1/3, do in your calculator, hit math, enter, and you're going to get positive 8/3. Positive 8/3 times negative 1/3 is negative 8/9. So we know it worked. Our missing number is positive 8/3. This, to just finish it off, is geometric because your pattern was multiplication, which means it's an exponential function. And we found that R is times negative 1/3. Nice and easy. Let's look at the next one. From negative 1/2 to 0. So again, I'm going to first check to see if it's arithmetic. So what could you add? If you're at negative 0.5 to get to 0, you would add 0.5 or 1/2. Just use the decimal. Is 0 plus 0.5 a half? It is. Let's see if our pattern continues. Well, if that's the pattern, 1/2 plus a half is 1. And 1 plus 0.5 is 3/2. 3/2 is 1.5 if you like decimals better. And 1.5 plus 0.5 is 2. So that works. So since our pattern is addition, this is arithmetic, which means it's a linear function. And D, our pattern, is plus a half or 0.5. So this is everything you should be able to do for these, each one. Let's look at this one. Nice and easy.
Easy squeezy lemon peasy.
This just wants us to know, is it arithmetic or geometric by looking at it? Well, this is, number one, is clearly not a line. It's an exponential function if you connected the points. So this is a geometric sequence. Okay. In number two, if I connected those points, it clearly would be a line. So this is arithmetic, or A. Easy. Let's look here. So this one says list the first 5 terms of the sequence below. So they gave me a sub 1, and then they gave me the pattern, and you have to understand what the pattern means. So in other words, it's saying a sub 1 is 17. So my first number is 17. To get to my second number, if R is negative 3.5, am I going to subtract 3.5?
No! No!
No, remember R means that it's geometric. So really, if R is negative 3.5, R is times negative 3.5. So if I have 17 and I multiply it by negative 3.5, do 17 times negative 3.5, I get negative 59.5. And then to get to my next number, I'm going to take that and multiply it by negative 3.5. And I get positive 208.25. And I'm going to continue till I get to the fifth number. So I have the first number, the second number, the third number. So I'm going to times it by negative 3.5. And I get negative 728.875. And last but not least, when I multiply it by negative 3.5, I get positive 2,551.0625. And you could have turned those into fractions if you wanted to, but you didn't need to because they're perfectly fine decimals. They ended. And you know you're done because you have 1, 2, 3, 4, 5 terms, and that's what they wanted, the first 5 terms. So there's number 1. I'm going to erase this and look at number 2. So same idea. They told me a sub 1 is 3, so my first number is 3. Now they told me D equals 1/2. So if they gave me a D, it means it's arithmetic. So that means D equals plus 1/2 or plus 0.5. So I'm adding, okay? So if my first number is 3, 3 plus 0.5 is 3.5. And then 3.5 plus 0.5 is 4. And 4 plus 0.5 is 4.5. And 4.5 plus 0.5 is 5. And they wanted the first 5 terms. So I've got 1, 2, 3, 4, 5. So it's really important to pay attention.
Pay attention to me!
To the variable they give you. If they give you an R, it means you're going to multiply. If they give you a D, you're going to either add or subtract. So if it's positive, you're going to add the number. If it was a negative, you would subtract the number. Okay, so this one wants us to write the formula for each sequence below, identify the starting value, and then find the fifth term. So first off, you have to be able to recognize what type of sequence it is, and then use the correct formula. So in number 1, they gave me a sub 1 equals negative 8 and D equals 4. Well, as soon as they give me D equals 4, I know it's arithmetic. The reason I know it's arithmetic is because for an arithmetic, the pattern is D. So my formula for arithmetic is a sub n equals a sub 1 plus D times n minus 1. to write the equation, a sub n equals a sub 1 was negative 8 plus d was positive 4, parentheses n minus 1. You're done. There's the equation. It also wants us to find the fifth term. So in other words, you're going to substitute in n equals 5. So I just like to substitute in after my equal sign. I'm going to do negative 8 plus 4, parentheses, and then if n is 5, so 5 minus 1. And in my calculator, I'm just going to do that in one step. Negative 8 plus 4, parentheses, 5 minus 1. And the fifth term is 8. Let's look at the one next to it. In the one next to it, number 2 says a sub 1, my first number is negative 5,000, and r is 1/5. So again, what type of sequence is it? Well, I know it's geometric, and it's geometric because the pattern for geometric is r. So if they give me r, it has to be geometric. Formula for geometric, a sub n equals a sub 1 times r raised to the n minus 1. We're going to substitute in to a sub 1 and r. So a sub n equals a sub 1 was negative 5,000. R was 1/5, and it's raised to the n minus 1. They want me to find the fifth term. So again, I'm going to substitute 5 in for the n after my equal sign. So I get negative 5,000 times 1/5 raised to the, if I want the fifth term, I'm going to raise it to the 5 minus 1. And in my calculator, I'm plug that in one step. Negative 5,000, parentheses, 1 divided by 5, 1/5 raised to the 5 minus 1. And I get negative 8. You could have also found the fifth term in your calculator. You could have gone to your y equals and like said y equals negative 5,000 times 1/5 raised to the x minus 1, and then just scrolled to where x is 5, and you'd see it's at negative 8. Same thing with the arithmetic one, the first one. You could have gone to your y equals and done negative 8 plus 4, parentheses, x minus 1, and just scrolled to where x is 5. Would have got you to the same place. All right. So let's look at this one. It says write an explicit formula for each sequence below. Be sure to identify the starting value. So here they didn't give me a D and an R, so I'm not necessarily sure what type of sequence it is. So we have to go back to 2 problems ago and say, okay, first we have to figure out the type of sequence, then we can write the equation. So here, let's see if it's arithmetic. I always do that first. So number 1, how do you get from a 2 to a 3? Well, I add 1. Does that pattern remain true? Is 3 plus 1 equal to 4.5? It's not. And if it's not arithmetic, your only other option is geometric. So to find R, you might want to take the second number, which is 3, and divide it by the first number, which is 2. So the pattern here is times 3 over 2, or if you don't like that, you can say R is times 1.5. Let's see if we are correct. 2 times 1.5 is 3, and 3 times 1.5 is 4.5, and 4.5 times 1.5 is 6.75. So we're good. So we know that this is a geometric sequence. We know that because the pattern is multiplication. The formula is a sub n equals a sub 1, parentheses r, raised to the n minus 1. We're going to substitute in a sub n equals, what's a sub 1? Well, my first number is a 2. So 2 times my pattern, which is 1.5, raised to the n minus 1. And we're good. Okay, let's look at B. Same idea. I'm going to first check to see if it's arithmetic, because I just think that's the easiest one to check first. So from a 5 to a negative 1. And again, you might struggle with this. You might say, all right, D is my second number, which is negative 1, minus my first number, so minus 5, which is negative 6. So let's see, 5 minus 6 is negative 1. Is negative 1 minus 6 negative 7? Yep. And negative 7 minus 6 is negative 13. So you're good. This happens to be an arithmetic sequence. How do you know? We know because our pattern is subtraction. So my formula is a sub n equals a sub 1 plus d times n minus 1. So we are going to just substitute in here. So my formula is a sub n equals, what's a sub 1? Well, my first number, that's a sub 1, is 5. plus d. So we just said that d is minus 6. So you can do plus a negative 6, or you can just say minus 6, parentheses, n minus 1. And there's this one's formula. Nothing new today, guys. We're just taking everything that you've learned and kind of mashing it together.
So happy together.
And a couple problems. All right, we only have a couple left. This one wants us to graph. So this one's f of n equals 3 times 2 raised to the n minus 1. If it's raised to the n minus 1, this has to be a geometric sequence. And we know that because n is an exponent. And if you don't know that, what I want you to do right now is go to your y equals and type in 3 times 2 raised to the n minus 1, or x minus 1 we have to use. Hit your graph key, and you're going to see that you have an exponential function. See, it's curved. It's exponential, so it has to be geometric. Now to graph this, it says graph the first 5 terms. So that means I'm going to start where x is 1, remember. I'm going to graph 1, 2, 3, 4, and 5. And I'm just going to use my calculator. So my first number was 3, which I knew anyways. My second number was 6, which again, you should know because this is your pattern is 2, and 3 times 2 is 6. So another way to do this is just know what your pattern does. Or again, use your calculator here. Okay, we're going to very quickly plot these points. So if you look, these are going up by 100s on your y. So I'm going to go over 1 up 3, which is like not a lot, and over 2 up 6, which is really not a lot, and over 3 up 12, which is still not a lot, and 4, 24, and 5, 48, which is about halfway. Might as well do 6, 96, okay, and 7. Let me look at my calculator. At 7, it is at 192. So I'm just going in a couple extra to get that curve look to it. Do not connect the dots because sequences are discrete. You don't connect the points. All right, let's see what other problems we have going on here. Sorry. So here we go. Let's look at this one. Wants us to graph this one as well. Now notice that the n minus 1 is not an exponent. It's down. It's the same size as the 2 and the 3. So this has to be an arithmetic sequence or a linear function. Okay, and again, how do we know? Is because it also has this addition symbol, so it has addition in it. So you can tell that your pattern is addition. To graph this, you can just go to your y equals and plug in 3 plus 2 parentheses x minus 1. Remember, when we're graphing sequences, we start where x is 1, so we're just going to graph 1, 2, 3, 4, and 5. If you go to your y equals and do 3 plus 2 parentheses x minus 1, you should notice that when x is 1, my very first number there would be 3. There's a sub 1. My pattern was plus 2, so you would notice that you'd have the point 2, 5, and 3, 7, and 4, 9, and 5, 11. So we can just quickly plot these points. So over 1 up 1, 2, 3. My pattern or my slope, because it's a line, is plus 2. So I can just go up 2 over 1, up 2 over 1, and it's going to hit all of the correct points. And I'm not going to connect them because it's a sequence, and sequences are discrete. We don't connect our points. All right. Let's look here. This might be our last one. I'm not sure. It says, given a term of the sequence and the common difference or ratio, write a formula for each. Be sure to identify the starting value. So this gave me a D. If it gives me a D, it's arithmetic. If it's arithmetic, our formula is a sub n equals a sub 1 plus d times n minus 1. Well, they gave me a piece of it. They gave me d equals 4. But they told me a sub 3 is 1,280. So that means my third term is 1,280. We're going to have to work backwards to find the second term and then the first term because we need a sub 1, which is the first term or where x is 1. They told us the pattern is 4. So in other words, if I was going this direction, I would add 4. So my fourth term would be 1,284, and then I would keep adding 4, which makes sense. To go backwards, again, to work until we get to 1, we just do the opposite. So if our pattern is plus 4, we're going to subtract 4. So 1,280 minus 4 is 1,276. And 1,276 minus 4 is 1,272. So there is a sub 1, 1,272. Now we can write the formula because we have a sub 1 and d. A sub n equals 1,272 plus 4 parentheses n minus 1. And there's our final answer for this one. A little bit more work because we had to work backwards to get a sub 1, but not tough. If you work backwards, you just change the sign. So if your pattern's addition, you subtract to work backwards. If your pattern was multiplication, you would divide to work backwards. Okay, so there we go. This is Unit 6, homework number 9 is attached to this. Make sure that it is in by Sunday. Email with questions, guys. Join the Google Meets. We only have a couple weeks left. You're doing great. And there's Corey for her debut. See ya.